Today we're looking at the minimum argument. How do you find the minimum argument given a certain values of z? So in this case, you have a circle given by z minus z1 equals r. So you got to change that into z minus z1 equals r form though. So the circle here is the center at 3 minus 4. So you go 3 minus 4. 3 minus 4 is here. So you go 2 up, 2 down, 2 across the left, 2 across to the right. I know it's not to scale, but that'll do. So that's 3, that's minus 4. And the minimum argument of z, this is the hard one. You have to remember the definition of z is the same as z minus 0. So this is basically the angle that the vector from O to z. So z can be anywhere along this circle here. Now by geometry, it just happens to be that the ranges of z would be there and there in terms of the argument. So the angle can swip between that tangent to this tangent here. Now, because z is down here, it's going to represent a negative argument every time you go down here. So let's say this is alpha, and let's say this is theta. Now, in terms of size, alpha would be smaller than theta. But in terms of argument, this would have to be the bigger argument, and this would be the small argument simply because it's a bigger negative number. So the minimum argument here, the minimum argument of z rather, is going to be negative theta, theta being the size of that angle. Now, how are you going to find that angle? Well, here's how you go. One of the property of circle is that the radius and the tangent through the point of contact is 90 degrees. There you go, like that. And then if I go like, that's O, that's A, that's C, and that's B, let's say, that's 90 degrees over here. That's not 90 degrees there, by the way. So let's make this angle, that's 90 degrees over there as well. Let's make this angle here, gamma. So let me draw that triangle here so you can see very easily. I'm finding a little bit blind so I can't see whether I'm out of thing or not. So let me draw that triangle again for you. So it's like this. There you go. 90 degrees is over here. The 90 degrees is over here. This is your gamma. The distance from here to here is basically by Pythagoras. So that's 3, that's 4. So that distance is 5. So that distance is 5. That's hypotenuse. This radius, which is 2. So basically gamma is basically that divided by that. And that's 90 degrees here, by the way. So that's sine inverse of 2 on 5, whatever that happens to be. Then you have another triangle here. So that triangle is like this. So you have that there. That's 90 degrees over here. That's 90 degrees over there. And then you got this angle here. So this is your, if that's A and that's O, then this here, let it be equal to, let's say, beta. And this is alpha, this is gamma over here, sorry, rather. Beta is actually going to be 4 and 3. Beta is actually tan inverse of 4 on 3. It's basically that angle. And so the minimum argument in this case is actually, you have the beta and the gamma, which makes up for the theta here. It's negative gamma plus beta. So in this case, it's negative tan inverse of 4 on 3 plus sine inverse of 2 on 5. And that's basically the minimum argument in this case. And that's how you do the minimum argument. And that's where I'm going to stop.